Hello everyone, welcome to the Tom class. This is our fourth session on the problem solving. We are studying the numerical questions. From theory of machine, we started with the analysis of planar mechanism, gear trains, flywheel. The major topics we have studied. Analysis of planar mechanism includes mechanisms and machines, velocity, acceleration, kinematics of links. And now we are studying the governors. We have solved few questions, and today we'll continue solving some more questions from the governors. Okay, and then we will proceed towards the next topics. Okay, so with that introduction, let's start the session. Okay. Let me check. I'm trying to take over the questions which we have not studied in past. Okay, the different one. So we have one question and about the Hartnell governor. I think last time we have studied, in the last session we studied the problems of the Porter governor also. Yeah, let's talk about the Hartnell governor. In a Hartnell governor, the mass of each ball is 2.5 kg. The mass of each ball is 2.5 kgs. Okay. Maximum and minimum centrifugal forces on the balls are 2000 and 1000 Newton. Maximum and minimum centrifugal forces on the ball. Centrifugal forces on the balls are 2000 Newton and 1000 Newton. Okay. So corresponding to radii 20 centimeter and 15 centimeter respectively. Corresponding to radii 20 centimeter and 15 centimeter respectively. Okay. Lengths of vertical and horizontal arms of the bell crank levers are the same. Lengths of bell crank lever are the same. Then what is the spring stiffness in? Then what is the spring stiffness in Newton per centimeter? Okay, so yes, try to solve this one. They are asking us to calculate the spring stiffness. So what is the given data? The mass of each ball is 2.5 kg. Okay, and minimum and maximum centrifugal force. F max is equal to 2000, and this is corresponding to the radius of, maximum is the radius, maximum will be the centrifugal force, right? So it is corresponding to 20 centimeters, and F minimum is 1000, and this is corresponding to the 15 centimeter R minimum. Okay. So, and they have also given A is equal to B. Lengths of all the bell crank levers are same, then A is equal to B. So K is equal to 2 times A by B whole square in bracket F max minus F minimum divided by R max minus R minimum. Okay. So A is equal to B. So 2 times F max is how much? 2000 minus 1000 divided by 20 minus 15. Okay. So it is 2 into 1000. That is again 2000 divided by 5, which will give you 400 Newton per centimeter. Okay. So the value of the stiffness, if you know this formula, you can easily solve the problem. Okay. So it's only based on this formula. Okay. Straightforward formula based problem. Okay. I think maybe one more problem I'll take on the Porter governor, and we'll proceed towards the next topic. Okay. I'll go to the next slide. Write down a question. In a Porter governor, all arms are of equal length. The Porter governor, all arms are of equal length. centimeter and are pivoted on the axis of the spindle. Pivoted on the axis of the spindle. Okay, on the axis of the spindle. The ball mass each is 1 kg and the top sleeve is 20 kg. The ball mass which is 1 kg and ball radius of 25 centimeter. Radius of 25 centimeter. The ball arm is vertical and the equilibrium speed is 20 radian per second. Okay, the ball arm is vertical and the equilibrium speed is 20 radian per second. Okay, if the spring stiffness is 200 Newton per centimeter, if the spring stiffness is 200 Newton per centimeter, the initial compression in the spring at this position is the initial compression in the spring at this position is the spring at this position is. Okay, so you have the options: 1 centimeter, 0.5 centimeter, 2 centimeter, 0.25 centimeter. Okay, try to solve this. Okay, let me check it once again. No. I think there is something wrong. 20. Just correct. Let me correct it. Ball mass each is 1 kg and ball radius No, from here I have written wrong. Okay, sorry. Please correct this. Secondly, written another question. Okay, 1 kg, fine. And that of sleeve is 20 kg. Sleeve is 20 kg. At a configuration, when the radius of rotation of the balls is same as that of the height of the governor, at a configuration, when the radius of rotation of the balls, the radius of rotation of balls is same as the height of the governor, same as height of the governor. Okay, height of the governor. The equilibrium speed in radian per second is equilibrium speed radian per second is okay. And the options are 17.5, 24, 30, and 35. Okay, now try to solve this. Okay, so what is given data here? um, height of the governor. Okay, is mentioned. He also mentioned about the ball mass of the sleeve. Height of the governor formula you know is G divided by m omega square, small m plus capital M times 1 plus k divided by 2. Okay, so this is the formula, right? When you don't have the friction, correct? So because you have not talked about the friction, so friction is 0. So this is what we'll see. Now on top of that, they have mentioned that the sleeve, all the arms are of equal length. Okay, so the value of k is equal to 1. If k is equal to 1, h is equal to g divided by m omega square, m plus capital M. Sorry. Yeah. So how much it will be? 1 plus 1 is 2, 2 m plus capital M. That's all. Okay, and now you can solve this. Okay, try to put the values here. Yes, so g by omega square into m plus m. So that is 20 plus 21 is 21. What? Okay, mass of mass is 1. Okay, g on the right hand side you will have g divided by 1 omega square into 21 plus 20, that is 21. On the left hand side you have the h, okay, height, which is 50 by root 2. Okay, because 50 centimeter, so it is 0.5 by root 2. 0.5 by root 2. Okay, 0.5 by root 2. And now yes, this implies omega is equal to 24. Okay, option B is correct in this case. So like this, you will solve the problems. Okay. Yes. Okay. Now we will solve some balancing problem. Write down heading balancing. Okay. Balancing of masses. If you remember the topic, we have studied both balancing of reciprocating and rotating masses. Okay. Yes, so that's the overall topic which we studied, right? So let's solve some questions on this. Just a minute, let me try to check some questions. Okay, yes, I think I have one more question here which we have not studied in past. A disc on a shaft, okay, a disc on a shaft has three masses, A, B, and C, full stop. Given MA RA equal to 8, MB RB equal to MC RC equal to 5. The disk is perfectly balanced. The disk is perfectly balanced. Okay. What is the angle between the radial directions of mass A and B? What is the angle in radial directions of masses A and B? Okay. Yes, start solving this. Options are like sine inverse of 0.6. Option B is sine inverse of 0.625. Tan inverse of 0.6 and tan inverse of 0.625. Okay. Start solving this question. Draw the figure first, then it will be easy for you to understand the problem. Okay. Let me try to solve this. A disc on a shaft has three masses A, B, C. Okay. I'm just drawing it randomly. Okay. I don't know. It's wrong maybe, but yes, randomly these are the of course theta B, and this is theta C. This is your MARA, MBRB, and MCRC. Of course, this is not balanced, but this is a very generic figure I'm drawing. Okay, a disc on a shaft has three masses A, B, C. Given MARA is equal to 8, MBRB equal to MBRC, MCRC is equal to 5. The disc is perfectly balanced. Okay, what is the angle between the radial direction of A and B? Okay. So this is something, theta B is something they are asking you to calculate. Okay. Okay, start solving this. Try to apply the equations of the equilibrium and then tell me the answer. Not that difficult. Okay, anyone? Any solution? Okay, let me solve this question. So, what you can write, MARA plus MBRB cos of theta B, okay, plus MCRC cos of theta C equal to 0. Um, so MARA is 8 basically, and MBRB, MCRC is 5. So 5 times cos of theta B plus cos of theta C is equal to -8. Let's call it as equation number 1. Okay. If you consider the vertical components, only MBRB and MCRC will have vertical components, right? MBRB tan of theta B plus MCRC tan of theta C equal to 0. All right. So MBRB equal to MCRC we know. So sin of theta B is equal to minus sin of theta C. Okay. Um, so you can say theta B has to be equal to pi plus theta C. Okay, because sine of 90° plus theta is minus sin theta. Okay, or you can also write it as theta B is equal to 2 pi minus theta C. Sine of 360° minus theta is also, sorry, sine of 180° plus theta is also minus sin theta, and sine of 180°, sorry, 360° minus theta is also minus sin theta. Okay, so this is should be the angle. Now you have one equation, and now you have this another equation. Okay, make use of this and try to solve. So if I put this equation 2 into equation number 1, or let's say if I put theta b value into this, theta b is equal to pi plus theta c. So everything, or theta c, from this I can calculate. Theta c will be um, theta c will be theta b minus pi. Okay, like this we can write, and then you can put it into the equation number 1 and write the whole equation in terms of theta b. So I'll say 5 into cos of theta b as it is plus cos of theta b minus pi is equal to -8. So if I take minus common, cos of minus theta is minus cos of minus theta is cos theta. So cos of pi minus theta b also I can write. Okay. So cos of 180° minus theta is what? Sorry. Uh, Cos of or maybe, I think you will get there. Yes, you will get cos of theta b plus cos of theta b. So in short, 2 cos theta b. So in general, pi into 2 cos theta b is equal to -8. This implies cos of theta b is equal to minus 0.8, and theta b in terms of sin of theta b also you can write from this. Sin theta b is equal to plus or minus 0.6. So theta b is equal to sin inverse of 0.6. Okay, option A is correct in this case. Okay, quickly write it down. Okay. Okay. Let me proceed to the next slide. There are not much questions. Okay, let's take 1 or 2 questions, which is very basic. Okay. Okay, this is one more question is there. So we have 5 kg. The radius is 2 meter. We have 1 meter radius, 3 kg, 45 degrees the angle. And then we have 10 kg. Again, 1 meter. Okay, so for a rotor system shown in the figure, the mass required for the complete balancing is, question is, for the rotor system shown in the figure, the mass required for its complete balancing is. Okay, so basically you have to calculate mass and so you have to calculate in general theta, mass and theta. Okay, so that is the options are given accordingly. I'll not write the options. So, but options are like 1 kg at a 2 meter radius and at this much theta. So not just mass and theta, you also have to calculate the radius. Okay. So 3 things you have to calculate here: mass, radius, and theta. Okay. Very important question. Okay. So you know how to solve this, right? You just do the force balancing. So M1R1, so 5 into 2, the positive side, plus 30 into 1 cos of 45 degree. Okay. And let's say you are adding some counter mass. We don't know. Let's say here, and at an angle theta. We don't know. Okay. Theta. And that mass is M, and radius is R. So 10 into 1. And then, okay, I don't know that. So that's why that theta. So I'll say it as plus MR cos of theta. Okay. We don't know how it is. Okay. Theta. Okay. And this is mass M, and this is radius R. Plus MR cos of theta I'm writing. Okay. I don't know whether it is positive, negative, how much, equal to 0. And now this is with this assumption you can proceed. So this is minus, sorry. So this 10 will get cancelled. 30. Not 30. 3 into 1 into cos 45. 3 into cos 35. Cos 45 is how much? 1 by root 2. So 3 by root 2 is equal to minus 3 by root 2 is equal to MR cos of theta. Equation number 1. And if you, this is summation of all horizontal moments is equal to 0. Okay. And here now summation of all vertical forces, if you calculate summation of all the forces, vertical forces, how much? 3 kg will create one force. Okay. That is again 3 by root 2 plus MR sine of theta equal to 0. This implies MR sine of theta is equal to minus 3 by root 2. Okay. So what we can understand from, let's say, equation number 1 and 2, your right hand 3 by root 2 will get cancelled. MR cos theta is equal to MR sin theta. MR will get cancelled. So tan of theta will be equal to 1. So I'll say from equation 1 and 2, tan of theta has to be equal to 1. Theta has to be equal to 225 degrees Celsius. Okay. Okay, and at that particular point, both your MR sin theta and MR cos theta will be negative. Okay. At 225 degrees Celsius, both sin theta and cos theta is negative. Correct. So the whichever option they have given, or you can just put it into equation number 1 and 2 and calculate the value of M and R. Okay. So and solve it. Okay. So equation number 1 was what? Equation number 1 was MR cos of theta is equal to minus 3 by root 2. So put here theta value and get the value of MR. Okay, from this. So the answer is directly I'll write is 1.5 kg at a 2 meters. Okay. Radius at a 225 degrees Celsius from reference. Okay, this is the answer. So theta we calculate. If you put it into this, you can clearly see cos of theta will be how much? Cos of theta will be 1 by I think minus 1 by root 2. So minus 1 by root 2 minus 1 by root 2 will get cancelled. MR is equal to 3 and 1.5 into 2 is 3. So that is only option. Use this. So hence it is correct. Okay. So it is very easy to solve the problems which are based on the balancing of rotating masses. When problem comes from the reciprocating masses, I'll just give you a hint. Balancing of reciprocating masses. So the first question for that is the primary unbalanced force due to reciprocating parts of weight W parts of weight W and with a crank radius R and connecting rod as L is. As L is. Okay. And the second question is secondary unbalanced force. Okay. So they have given options, but I'll directly write the solution. And the other things are same, secondary unbalanced force. Okay. Yes, and all other things. So you should know, as far as reciprocating masses is concerned, what is the primary unbalanced force and the secondary unbalanced force. Okay. So the primary unbalanced force is W by G, or let's say MR omega square cos of theta. Okay. Secondary unbalanced force is MR omega square cos of 2 theta by n. Okay. MR omega square cos of 2 theta by n is your secondary unbalanced force, and primary unbalanced force is MR omega square cos of theta. Okay. So if they ask you to calculate this, they may give you the numericals, but if you know this formula, you can directly substitute into this formula and solve it. Okay. So nothing is difficult as far as the topic balancing is concerned. Okay. Maybe I'll take one question on that. We have already studied this, okay, in past, but just to refresh your mind, I'll take it again. In an IC engine, the length of connecting rod is 10 centimeter. Connecting rod is 10 centimeter, and that of crank is also 10 centimeter. That of crank is also 10 centimeter. The mass of the piston is 1 kg and the crank is 1 kg, and the crank is rotating at a speed of rotating at a speed of 1 radian per second. The primary and secondary forces when the crank is perpendicular to the connecting rod are given by the primary and the secondary forces. Okay, when crank is perpendicular to connecting rod are given by. Okay, options. Okay, 1 Newton, 0.5 Newton, 0.07 Newton, 0 Newton, 0.1 Newton, 0 Newton, 0.07 Newton, 0.075 Newton. Okay, these are the options. You know, these are directly formula based questions. Okay, you know, primary unbalanced force in case of reciprocating masses is mr omega square cos of theta. Okay, the mass of the IC engine is, sorry, mass of the piston is 1 kg. Radius is 10 centimeter, 0.1. Omega cos of much. What they are saying is crank is perpendicular to the connecting rod, so this is 90 degree. Both these angles has to be 45 because length of connecting rod and crank is the same, right? So it is cos of 45, I would say. Correct, because this is theta and this is phi as far as I remember. So 0.1 into 1 by root 2. Try to solve. 2.1 divided by root 2 is 0.707. 7071. Okay, so that is the answer. Secondary unbalanced force is equal to mr omega square cos of 2 theta divided by n. Okay. Yes. Cos 90 is 0. So secondary unbalanced force is 0. Hence option B is correct in this case. Okay. Clear? Are you following? Feel free to ask if you have any questions. Okay, just a minute. The next topic is gyroscope. There are not much questions on these, like, okay, the major topics we have already studied, so very less questions. Let's take a question on the gyroscope. So write down heading gyroscope. Okay, so we understood the gyroscopic effect here. We understood the formula for the gyroscopic pulse. How exactly, let's say, the gyroscopic effect looks like when we have, let's say, different applications. For example, we started with the aeroplane. Aeroplane is moving, rotor is rotating clockwise direction, takes a left turn or right turn. How exactly the effect of gyroscopic couple will be there in this case? Same way, or the direction of rotation changes, how exactly the gyroscopic effect also changes. Then we took the example of ship. Okay, the rotor of the ship is rotating, and then ship takes a left turn or the right turn. On that basis, we understood how exactly the gyroscopic effect will be there, right? So there are different motions like pitching, yawing, and steering, right? So um, I think yes, steering and yawing is same. Then we have pitching, and the other one is rotating. Okay, the rotation will not create any gyroscopic couple, but other things like steering or yawing on the pitching will create the gyroscopic effect. Then we studied the what you call in bicycles, sorry, or two-wheelers basically, two-wheeler and four-wheelers. How exactly the uh, um, yeah, how exactly the gyroscopic couple will look like and effect will look like. So this is all about the theoretical background. Now let's understand some questions. Okay, as I don't have much questions, some of the questions I'll take which are like already um, solved. Okay, and yes, okay. Okay. So for example, if I give you a first example, we have an air screw or it's aeroplane which rotates in a clockwise. Aeroplane rotor or screw rotates in a clockwise direction when viewed from the rear end. So imagine, let's say this is the aeroplane. When uh, you check it from the rear end, okay, when you check it from the rear end, it rotates in a clockwise direction. Okay, clockwise. Okay, this is given data. Now, question is, if aeroplane takes a right turn, it takes the right turn, the gyroscopic effect will be, okay, the gyroscopic effect will be the okay. So linear velocity vector, so you will use the right hand thumb rule. So if your four fingers represents the orientation, or let's say the sense of rotation, which is clockwise, those so the thumb will indicate the direction of the angular velocity vector. So it will be towards right hand side. So I'll call it as OA. Now it takes a right turn. Aeroplane takes a right turn. So OA dash is your new angular velocity vector direction. So A to A dash is the active torque and A dash to A is the reactive torque. Reactive couple. Okay. And then if you put your thumb in this arrow direction, how exactly the this is how your um, this is how your the effect will look like. So it is like this. So it will basically, let me draw using red pen. So this is the gyroscopic effect. So if you look it like this, it will be basically tend to rise the tail. Okay. Okay. This will tend to rise the tail and lower the stern. Okay, lower the stern. Okay, now if it takes a left turn instead, what will happen? If it takes left turn instead, let me show you. Same thing. It is rotating in clockwise direction, but it takes a left turn now. So your active torque is like this, OA, and this is A dash, and this is your reactive torque. And now if I put a thumb in this direction, it is like this. Okay. This is left turn. This is the right turn. And if it takes a left turn, it is opposite. Tend to rise this turn and lower the tail. Okay. Okay. Not stern basically. Tend to rise the tail and lower the nose. Stern is something we use in the ship. Okay, so let's use the nose and the tail concept. Okay. So like this, you can solve the problems. Okay, let me check any another question. Okay, we have another question. The shape of the rotor rotates in a clockwise direction when viewed from the stern, and ship takes the left turn. So stern is like kind of a backside area. Let's say this is the ship. So this is called as stern, and this is called as a bow. And we have, let's say, a rotor here. And if you are looking from the stern side, the rotor is rotating in a clockwise direction. Okay. So we have the angular velocity vector OA, and it takes a left turn, OA dash. Angular, this is your active torque, and this is your reactive torque. And if I put a thumb in this direction, it will be counterclockwise. Okay, and the other four fingers will be in the counterclockwise direction. So it will lower the stern and um, raise the bow. Okay. So it is taking left turn. So ultimately, you can say that raise the bow and lower the stern. Okay, let me check here what I have written. I think it is correct. Okay, so this is some basic theoretical questions you should be able to solve without any numerical, just by drawing the figure. You can solve whether it's a shape, plane, anything. Okay. Now, numerical questions. What kind of questions they can ask? Okay. This question we have already solved, but I'll just take it again. The moment of inertia of the aeroplane. Um, okay. Moment of inertia of aeroplane air screw I is equal to 20 kg meter square. Okay. And the speed of rotation is 1000 rpm. Clockwise when viewed from the front. Okay, when viewed from the front, the speed of the light is 200 kilometers per hour. Speed of flight, sorry, 200 kilometer per hour. So find the gyroscopic reaction on the air screw on the aeroplane when it makes a left-handed turn. When it makes left-handed turn on a path of 150-meter radius. On a path of 150-meter radius. Okay. Try to solve this question. Gyroscopic effect. Try to draw the figure, at least the uh, angular velocity vector figure you have to draw, and based on that you can solve this. Okay. Okay, solve it. Okay. Okay, so let's try to solve this one. I is the moment of inertia. 20 ag meter square, and the speed of rotation omega is 1000 rpm when viewed from the front. So let's say this is the aeroplane. Okay. When you view from front side, yeah, the speed of rotation is clockwise. Okay, clockwise. Sorry, like this, because you're looking from this side. Okay, clockwise. Now, if you try to draw the figure of this, how it will look like? So we have this angular velocity vector on the front side, OA. It takes a left turn. Okay, so this is A dash, active torque, and then A dash to A is reactive torque, and then if I put a my four fingers in this direction, it will look like this. So like this will be the effect. So first of all, front part will go down and rear part will go up. So the gyroscopic effect is nose will lower and tail will go up. Okay. Second thing, what we can conclude here is the gyroscopic couple I omega omega p. Okay. I omega omega p is a gyroscopic couple. So the value of I is given 20. Omega is given 100 rpm, 1000 rpm. So corresponding to 1000 rpm, I think you will get it as 104.67 radian per second. 104.67, and omega p you have to calculate. How will you calculate the omega p? Is V is equal to R omega p. So from this, V is known, R is known, omega p can be calculated. Omega p is equal to V is how much? 200 kilometer per hour. So 1000 divided by 3600 divided by the R is how much? 150 meter. This will be like 0.37 radian per second. Okay, radian per second. And so it will be 0.37. And yes, finally the answer will be 775.5. Okay, 775.5 Newton meter. Okay, so I think that's there. If you have any questions, feel free to ask. Yeah, I think there are not much questions. Okay, even from camps, yeah, we have solved some questions in past. I think those will be sufficient. It is not so important topics. Important topics from the Tom, I would always say, the analysis of the planar mechanics. Definitely, you will get a question. Gear train, most likely you will get the question. Okay, and then maybe the flywheel governors or the gyroscope, or maybe the balancing.
You are currently the only person in this conference.
Okay, I think I got disconnected. But okay, anyways, what I'm trying to say here is now is we have studied the problems. Okay, I think this should be sufficient for you to give an overview, clear overview of what kind of difficulty level you can expect in the exam and what are the possible areas in these all chapters. Okay, let's make use of our WhatsApp group if you have any further questions. But I think we can end our session early today since yeah we have covered almost all the topics and yeah the problems associated with it. We have given more emphasis on the topics which are very important. Okay, these topics are like you will hardly find some problems, but still we studied them. Okay, but yeah, I would suggest you to do more practice, solve previous year questions. Okay, these are all not the previous year questions. So you have, if you solve the previous year question papers, you will get some more questions. Okay, means will have some more set. So that will be really useful for you. Uh, some of the previous year questions we have solved in the beginning, but the ones which are solved in these last 4 sessions is apart from that. Okay, but yeah, I would still recommend you to solve previous year questions. That will give you the further more clarity. Okay, so that's all for today. Let's thank you all for joining this session and let's keep in touch. Okay, you have 1 more minute, almost 1 more month. Make proper utilization of it. Make a plan, daily plan. Okay, and I would suggest start solving papers if you have not done. Okay, if you have not yet started, start solving full length paper as much as possible. Daily one paper you should solve. Okay, that will give you the clear progress. Okay, that will calculate your clear progress. You can join the online test series. Some institutes are giving free, some of them are giving paid. But yeah, my suggestion will be to solve as much as possible mock test papers or the full length papers. Okay, that will give you the overall idea. And then if you don't find it, it's fine. You can also print the previous year full length paper, sit for 3 hours and start solving it. Okay, and then calculate how much marks you are getting. That is also one way. Okay, and whatever exams are given by institute, that you can use mock test papers. So in that way you can solve like a lot of questions, full length question papers in this last month. So yeah, this is a smart way to study. I don't want you to go through all the topics again and again. That will not help you a lot. Solving the full length papers will give you clarity. Okay, your time management will improve, and then rest of the time you can spend in revision. Okay, you have studied maths, you studied let's say Tom, and then do the revision quickly. Daily, like 2 days for one subject or something like that you can spend. And yeah, major timing, major let's say the time you will give it for the at least 3 hours daily you should give it for the full length paper. Okay, 3 hours for full length paper, maybe half an hour for the problems which are difficult. You can just check the solution, how they are solved, and then you will learn. Like that you will learn. Okay, so and then the rest of the time, maybe 2 more hours or few more hours, you can spend on the revision of one particular subject. So you can cover maybe one subject in 2 days or like that should be your plan. Okay, because we have less time since we are doing revision, it should be faster, right? And then in that way you can easily do the proper revision within 1 month, as well as you can solve at least 30 full length papers. Okay, that will give you perfect overview. So that's so I would suggest you to plan your last 30 days and then work accordingly. Okay, don't just go with flow. Okay, these days will go faster, and yeah, make very good utilization of. If you are studied in the May, June, that's very good. But if you don't study now, and if you studied there, that will not help you. If you have studied less in the beginning, but now you are putting a lot of efforts, that will save you. Okay, so again, I'm saying, even if you have done the put the efforts in the beginning or not, that will not matter much if you put efforts now. Okay, the efforts for last month are very, very important. So that's my experience, and that's the suggestion I would like to give it to you. And let's keep in touch. And yeah, thank you all for joining this class. Thank you. Bye. Good night.